first of all, it's all that. And the excitement was in part because so much could have gone wrong with this thing. And the fact that nothing went wrong, we were ecstatic.
Could you explain how complicated it is to get something like that?
Yeah, so one of the great challenges that we face is how do you put a telescope in orbit that's bigger than the rocket that's going to launch it? Is that even possible? And the Hubble telescope, do you know what set the size of that? 94-inch diameter mirror. That's the biggest mirror you could fit in the payload of the space shuttle. Oh. That's what set the size of that telescope. Big as it was, we would have made it bigger if the space shuttle were bigger. Now, I don't know if you've seen the Hubble telescope. There's a replica of it at the Air and Space Museum.
Let's look a photo of it.
And it's there hanging from the ceiling, but if you want to know how, it's about the size of a Greyhound bus. So the space shuttle deployed a Greyhound bus into orbit, which is the Hubble Space Telescope. And the value of the Hubble was that you could update it with servicing missions, and it was serviced many times. And as a result, it lived within our culture for 3 decades. There are people who came of age only ever knowing the majesty of the universe as delivered to you by the Hubble telescope. 30 years worth of this. Think about it. Most other telescopes, they put into orbit and they have a 5-year mission and then they come down. So they don't have a chance to get inside you, to become something that you you got a nice visual there. So that's the Hubble telescope on the left, which every year I post a tweet at the end of the Stanley Cup. And I say, the Stanley Cup and the Hubble telescope had the same designer.
Really?
No, I'm just kidding. No, just look at the thing.
Oh.
It looks like the Stanley Cup.
A little bit.
Just a lot.
I wouldn't confuse the two if they were in a room together.
So here's the thing. So notice the Hubble telescope, its diameter is the spherical shape that fits in the spherical payload of the space shuttle. So now we want to put a bigger telescope into orbit. How do you do that? And so this is where you need engineers, clever engineers. We say, here's a rocket, one of the most powerful rockets we can use, but the fairing, that's the place where you hold the payload, can only be so big. And they say, all right, why don't we fold the telescope? Now, how are you going to fold the mirror? Oh, you turn the mirror into segments, hexagons. Hexagons, one of only 3 shapes that can tile a surface: a square, a triangle, and a hexagon. No other shape can do this. So, well, you can have other irregular shapes that can match up. You can tessellate, what it's called. But if you have what's called a regular polygon, so here in the image there, what you can see is all of the mirror segments. Those fold into a narrow structure along with the unfurling solar panels as well as the heat shields. Notice it was made at Northrop Grumman. By the way, Grumman has a long history in helping NASA put stuff in space. The LEM, Lunar Excursion Module, remember that? The thing that landed on the moon? That was designed and built in Bethpage, Long Island at Grumman Aerospace. And so this is, and you go to Bethpage today, people still stand tall because they had aunts and uncles who worked on that project. Space is a force of nature unto itself in our sense of pride, in our sense of achievement, and our sense of what operates on civilization to take us into the future, lest we continue to regress and move back into the cave, which we came. There it is, all folded up in the image we now see for those who are watching this. And you slip that into a fairing, and then you launch it 1 million miles from Earth, opposite the sun from Earth. And it unfurls like petals of a flower.
Is there an animation of how that goes down?
Yeah, they have slow-mo animation. Sure, he can find it. And it's the deployment, how it deployed as it was on its way to its location, which is one of the Lagrangian points in orbit.